Have you ever gazed into the night sky and spotted a faint, hazy patch of light, almost magical in appearance? What if I told you this isn't the work of a wizard's wand, but a cosmic phenomenon right within our galaxy? This is a nebula, a giant cloud of dust and gas where stars are both born and die, playing a crucial role in the very existence of the universe as we know it. But here's something even more fascinating. NASA's James Webb Telescope has recently revealed astonishing details about one such nebula, offering a glimpse into these stellar nurseries like never before. Today on YOUniverse Revealed, we're delving into the Webb Telescope's latest discovery, a captivating image of a nebula in the Taurus constellation so unique that it looks like milky white smoke emanating from the depths of space. Join us as we uncover the secrets of the mesmerizing Crab Nebula. Before we start with the Crab Nebula, let's first understand some basics about nebulae and their characteristics. The world of nebulae is all about swirling clouds of hydrogen, helium, and cosmic dust. Nebulae are born in the void of interstellar space, where low-density gas as well as dust exist between the stars. This void is vast to the extent that it holds as low as 0.1 atoms in a single cubic centimeter. You could imagine the magnitude of this emptiness if you knew that the air we breathe on Earth has 10 million trillion molecules in 1 cubic centimeter. Wow! In order to deep dive into the story of Crab Nebula, we will have to get transported back in time to the remarkable year of 1054 AD, the year in which a spectacular supernova explosion startled people for weeks. This explosion was so brilliantly bright that it remained visible in the daytime sky for several weeks, leaving observers in utter astonishment. The remnants of this supernova were later known as the Crab Nebula, also known as Messier 1, M1, and NGC 1952. The Crab Nebula is the aftermath of the 1054 AD stellar explosion. Since the explosion, this nebula has become a subject of research and study. Located 6,500 light years away from our planet, the Crab Nebula spans across many light years. The nebula is a celestial wonder and holds immense importance. The nebula's significance lies in its role as a vital resource for studying the aftermath of explosive supernovae and the unraveling of mysteries surrounding neutron stars. It has an intricate structure with a fantastic fusion of gas and dust and is brimming with the illuminating radiance of the pulsar's electromagnetic waves. Curious about pulsars, neutron stars, and all those intriguing scientific concepts? Don't worry, we're about to dive into all of it very soon. The Crab Nebula is a comparatively nearby supernova remnant that makes it easier for astronomers to understand the conditions, behavior, and the lingering aftermath of a supernova explosion. Due to its close proximity and distinctive features, it offers multiple opportunities for scientific exploration and continues to captivate scientists, making it one of the most studied objects in the night sky. No doubt this nebula has been attracting astronomers for centuries. It is indeed the apple of many astronomers' eyes. Now let's jump into the most interesting part. The Crab Nebula has caught the eye of NASA's James Webb Space Telescope, and scientists want to make the best of this opportunity to comprehend the whereabouts of this nebula. Therefore, an extraordinary cosmic expedition began with the brilliant minds at Princeton University under the leadership of Tia Temim. Their goal was to go deep into the mysteries of the Crab Nebula and to uncover the secrets of its origin. Having a telescope as powerful as the James Webb Telescope, they were armed with the incredible power of Webb's NIRCam and MIRI. Webb's sensitivity and precision are par excellence, and with its exceptional technology, Webb can enable this dedicated team to discover the intricate composition of the crab's remnants. In particular, they could reveal secrets hidden within the content of iron and nickel, which might reveal what type of explosion led to the nebula's birth. At first glance, the general shape of this nebula resembles the optical wavelength image captured by NASA's Hubble Space Telescope in 2005, but Webb had to reveal its magic, and it did. Webb's infrared observation gave scientists a sight to behold, a stunning cage-like structure composed of delicate gaseous filaments, one that radiates a vibrant palette of red-orange hues. And that's not the end of Webb's Crab tour. Webb also took scientists on a journey through the heart of this nebula, and for the very first time, humanity witnessed the intricate mapping of dust grains in the Crab Nebula. The beauty of these dust grains were captured in the colors of yellow, white, and green. The infrared light captured by Webb gave light to a whole new dimension of its inner workings and made the required details more prominent than ever. Webb gazed at the Crab Nebula like never before, highlighting something yet again that left scientists in wonder. It detected emissions from a particular type of radiation known as synchrotron radiation. Now, what exactly is that? So synchrotron radiation is produced by charged particles, which are electrons that race along magnetic field lines at tremendous speeds, reaching close to the speed of light itself, known as relativistic speed. So the milky white smoke that appears in most of the Crab Nebula's interior is actually radiation. This is a direct result of the powerhouse known as the nebula's pulsar. What's a pulsar? After the supernova explosion of a massive star, the gravitational collapse of the remnant of the star, which is nothing but densely packed neutrons, comes together to form neutron stars. The only condition that applies here is that the star shouldn't be massive enough to end up as a black hole. These neutron stars, when rotating rapidly, are called pulsars. Imagine a neutron star rapidly rotating and generating a magnetic field that's so strong that it propels particles to unimaginable speeds. And these particles wind around the magnetic field lines. They emit immense radiation. Well, the universe is a magical place, I tell you. Crab Nebula's pulsar is about 28 to 30 kilometers in diameter and spins approximately 30 times per second. Such speed is beyond imagination. And guess what? Because of Webb's NIRCam instrument, we can now witness this cosmic phenomenon of synchrotron radiation in a level of detail never seen before. As you can see, Webb makes anything possible, but discovering the pulsating heart of the Crab Nebula is surely no easy feat for us. So if you're wondering where to spot the heart of the Crab Nebula, we'll make this easy for you. To start with, trace the intricate pattern of circular ripples in the middle that lead to the radiant white dot at its core. As you move out from the core, follow the thin ribbons of radiation colored in a delicate shade of white. These curvaceous wisps are closely knit together. They outline the mesmerizing structure of the pulsar's magnetic field, which carves and molds the entire nebula. At the center and on both sides of the nebula, the white material sharply curves inward from the edges of the filamentary dust cage, almost like it's being pinched in the waist of the nebula. But what's causing this abrupt slimming? Well, it's likely the result of the wind's expansion of the nova that is being confined by a belt of dense gas. Confused about what this unexplained wind expansion is? No worries. So the thing is, the pulsar's beating heart generates a powerful wind that relentlessly propels the surrounding gas and dust shell outward. Inside the remnants, vibrant filaments of yellow, white, and green intertwine to form magnificent loop-like structures. It is these structures that indicate the presence of dust grains in those areas. Astronomers are on a mission to uncover the secrets of the Crab Nebula's history, and with continuous analysis of the Webb data, as well as cross-referencing the observations from other telescopes, they are sure to find answers. Moreover, newer Hubble data has been captured through a re-imaging process of a supernova remnant. It will soon be available for review in the upcoming year or so. The excitement is building, and this eagerly awaited moment will mark the first time in over 2 decades that Hubble will examine the emission lines from the Crab Nebula. The opportunity to compare the findings of Webb and Hubble will provide astronomers with a more precise understanding of this intriguing cosmic wonder. Well, that's definitely going to be one of the most interesting comparisons. And why shouldn't it be? It is within these nebulae that the universe unfolds its most visually stunning cosmic treasures. These treasures talk about the history of those twinkling stars that give us a glimpse into the wonder and mystery of the universe's creation itself. After all, it's a cosmic wonderland where stars collide and explosions light up the sky.